All right, hi guys. This is your notes for lesson 4.6, the quadratic formula. Starting with our warm-up, it asks us to factor the quadratic equation. So when we factor, we first need to start with identifying a, b, and c. In this case, a is 1, b is 7, and c is 3. Our next step is to move on to creating the table. We have a times c at the top, 1 times 3 is 3, and at the bottom we have b. Now we need numbers that multiply to 3, and the only numbers that multiply to 3 are 1 and 3. In this case, they need to multiply to 3 and add up to 7, but 1 plus 3 only equals 4. Because no other numbers multiply to 3, and they don't add up to 7, in this case, this is not factorable. Now, this doesn't mean that we can't solve it, but we just can't solve it by using factoring. So with this, we could use the quadratic formula. Could solve using quadratic formula. All right, so our learning target is that you can use the quadratic formula to calculate solutions. When we're talking about solutions, we mean the x-intercepts, roots, zeros, and what's the other number? What's the other word? X-intercepts, roots, zeros, solutions, duh, solutions. So your success criteria, these are your steps. We can verify that the equation is in standard form. Standard form is the ax squared plus bx plus c equals 0. You can identify a, b, and c, calculate the discriminant to determine the number of solutions, substitute the values into the quadratic formula, put in calculator, and then solve for x and simplify. All right, so to get started, the quadratic formula. Here is our quadratic formula. There is a song that we use to help us memorize the quadratic formula, and the song is sung to, well, I can't remember the name of the song, but it goes like this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, I'll sing it for you again. And I'll highlight as we go. Starting off on the wrong note. Okay, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So there's our quadratic formula. If you'd like to hear me sing it again, just rewind it. Okay, I forget what that song is called, but when we calculate the quadratic formula, we first need our equation to be in standard form, which we've written the standard form up there, but let's write it again just to be sure. Standard form is ax squared plus bx plus c. And the numbers that we're plugging in into the quadratic formula are coming straight from standard form, the a, the b, and the c. These are the numbers we're plugging in here to calculate the x-intercepts. So this portion with the square root and everything inside, this is called the discriminant. And the discriminant helps us to find the number of solutions and what type. So the discriminant tells us the number of solutions and the type of solutions. When we say type, we mean this could be non-real or imaginary. Or it could be a real solution. All right, so if okay, let's actually do this. Let's scribble out the square root. I hate that I keep forgetting to remove that. So the discriminant is only the b squared minus 4ac. It is not the square root, so don't get that confused. It's just everything inside the square root. Now, if the discriminant, what we calculate from the discriminant is a positive number, that means we have two real solutions. So two real solutions could look like this. If the discriminant is equal to 0, that means we only have one real solution. And what that could look like is we have one x-intercept and it touches the x-axis right there. Now, if our discriminant is a negative number, that's when we find that we have two imaginary solutions. And what that could look like is a parabola that does not touch the x-axis. So let's make a note here. The one that equals 0, the vertex is on the x-axis. And where we have two imaginary solutions where the discriminant is negative, this parabola does not cross the x-axis. Okay. Let's also star these three at the bottom because these, you might see a question like this on your test. That says test question. All three of these could be a test question. All right, if you need more time, pause the video. I'm going to move on. Now, on the back, I have it written down. The song is to the tune of Pop Goes the Weasel. I'll write that at the top over here. Sing to the tune. Cannot spell today. Tune of Pop Goes the Weasel. Yeah. All right, so moving on to the back. Here is our quadratic. Here are our steps over here on the left. First, we need to verify that the equation is in standard form. Is this equation in standard form? What do you think? If you think yes, then you are correct. It is in standard form. That means we can go right into step 2, identify A, B, and C. So let's start with A. A is 1, B is 7, and C is -3. Don't forget that sign. Step 3, identify the discriminant to determine the number of solutions. Calculate the discriminant to determine the number of solutions. Okay, so we said the discriminant is everything inside the square root, but not the square root itself. So we need to write out our discriminant. And our discriminant is everything inside. So we start with b squared. What is our b? Actually, let me just write it. B squared minus 4ac. So what is our b? Our b is 7. So we have 7 squared minus 4 times a and times c. What is our a value? 1. And what is our c value? -3. Now, this is something we can put into, let's actually put parentheses around the 7. This is something we can put in the calculator. When we put it in the calculator, we should get 61. I don't have a calculator on me, so I'm just going to calculate it really quick. 49 plus 12, which gives us 61. So the discriminant is equal to 61. That is a positive number. If we go back to our notes from before, we said if the discriminant is positive, we have 2 real solutions. So in this case, we have 2 real solutions. And I want you to write that next to your answer. 2 real solutions. Now, because we have 2 real solutions, we should be getting 2 solutions for x when we solve, because we're not done here. We're going to take the discriminant, use a different color. We're going to take the discriminant and plug it back into the square root. So we're going to have everything else in the formula, just not the b squared minus 4ac. Instead of all that, we're going to put 61. So let's copy down our quadratic formula. Let me leave a little more space for myself. Let's say x equals -b. What is our b here? 7 plus or minus the square root of the discriminant, which is 61. And then we divide it by 2 times a. What is our a value? 1. So now we have something that we could simplify just a little bit. What do we need to simplify? Well, we have this negative in front of the 7, and we have the 2 times 1 in the bottom. Now, this, the square root of 61, that is not a perfect square. So we'll just leave it like that. So simplifying this, we're going to say our x is equal to -7 plus or minus the square root of 61 over 2. And this is our 2 solutions. We have a -7 plus the square root of 61 over 2, and then we have a -7 minus the square root of 61 over 2. So if I wanted to draw a picture to show you what I'm talking about, I could have a parabola, something like this. And on the left-hand side, we would have this point would be -7 minus the square root of 61 over 2. And this point over here would be -7 plus the square root of 61 all over 2. These would be your 2 points, okay? So again, the way we're separating it into 2 solutions is the plus the square root and the minus of the square root. Okay, let's take a look at number 2. Now, before we move on to this one, I would like us to look back at our steps here, and I would like us to add a little step in between step 1 and 2. And we're going to say here, we will factor out we'll say GCF if possible. Now, if it's not possible, then we just move on to the next step. All right, let's take a look right here. Pause the video if you need more time. First, we need to check, is our equation in standard form? No, it is not. We need to move this -8 to the other side. So how are we going to move it? We're going to add it, leaving us with 2x squared plus 8x plus 8 equals 0. Now our new second step says factor out the GCF if possible. Well, between 2, 8, and 8, what are they all divisible by? What is the largest number they could all be divisible by? If you said 2, your answer is correct. We're going to factor out a 2. And that 2 doesn't disappear, it goes in front of a set of parentheses. And what goes inside is what we get when we divide each of these terms by 2. So 2x squared divided by 2, we're left with x squared. 8x divided by 2, 4x. And 8 divided by 2, we're left with 4. Now we can identify our a, b, and c. So in this case, our a is 1, our b is 4, and our c is 4. Let's do this over here. A, B, C. 1, 4, 4. All right, so now that we have A, B, and C, we need to write out our discriminant. Actually, I'm sorry. I'm going to move this over here, and we'll do the discriminant on the left side. All right, A, B, and C. We'll start our discriminant. So again, our discriminant is b squared minus 4ac. So plugging in our numbers, b is 4. B is 4. A is 1, and C is 4. Notice how I'm using parentheses for everything I plug in. If you're going to use your calculator, it's very important that you use parentheses on everything you're plugging in. All right, let's calculate. So putting this in your calculator, you should get 0. Doing it by hand, 4 squared is 16, and -4 times 4 is -16. That ends up being 0. So because our discriminant is 0, how many solutions do we have? We look back at the first page. If your discriminant is 0, you have one real solution. So this means we have one real solution. Now we can start to take our discriminant and plug it back into the formula, to the quadratic formula. So we're going to say x equals -b plus or minus the square root of whatever, all divided by 2 times a. So now I'm going to plug these numbers in. -b, b is 4, and then our discriminant, what goes inside the square root, is that 0. And a is 1. Now, this is something you can put in the calculator. If you put it in the calculator, you have to do, well, let's just walk through it. Really quick, the square root of 0 is just 0. So adding or subtracting 0 to something is not going to change anything. So the square root of 0 will cancel itself out. Continue solving, we have -4 over 2, which leaves us with -2. So our one solution is x equals -2. And if we wanted to draw a cute little picture to show our solution, we would have one x-intercept at -2. All right, let's take a look at the last one. Last example here. We have three numbers, 3, -8, and 10. Is this equation in standard form? Yes. Can we factor out a GCF? No. The only things that are divisible by 3 are 1 and 3, and 8 and 10 are not divisible by 3. So we'll leave that as is, and we'll go into identifying A, B, and C. Where A is 3, B is -8, and C is 10. Now our step 3 says calculate the discriminant. So we're going to plug these numbers into our discriminant. Sorry for the bell. Our discriminant is b squared minus 4ac. So when we plug it in, we have something squared minus 4 times 2 somethings. So b is -8, a is 3, and c is 10. Calculating this, if you put this in the calculator just like this, you should get -56. Doing this by hand, we would get 64 minus 40 times 3 is 120. And 64 minus 120 leaves us with -56. So because our discriminant is equal to a negative number, looking back on our last page, if the discriminant is equal to a negative, we have 2 imaginary solutions. So this means we have 2 imaginary solutions. All right. Now we're going to plug that -56 back into the quadratic formula. So we have x equals -b plus or minus the square root all over 2a. Plugging our numbers in, b is -8. Our discriminant is -56, and a in the bottom is 3. So when we simplify this, we do need to simplify the square root of -56. That square root of -56 is going to leave us with a complex solution. So if we simplify this, we have a -56 inside the square root. And we know that the square root of a negative number can be separated from the square root of 56. And the square root of 56, how can we simplify that number? 56, what 2 numbers multiply to 56? You guys can do the factor tree for 56, or you can do the perfect squares method that I taught my 5th period. So 56, we know 4 times 44, oh, I'm so sorry, 4 times 14 is 56, 2 times 2 is 4, and 2 times 7 is 14. So simplifying this, we have 1 pair, they go out, and the singles stay home. So this is our simplified square root here. If you use the other method that I taught my 5th period, the square root method is, we could split the 56 to being the square root of 4 times the square root of 14. If you're in 8th period, don't worry about this. Square root of 4 is 2. Square root of 14 stays. That square root of -1 comes down. All right, so how do we simplify this? We end up getting square root of -1. This is I. Square root of -1 is I. We talked about this last week. So we have I times 2 square roots of 14. So really, because we're taking the square root, we have plus or minus 2i square root of 14. Now this is what's going to go back into your equation instead of the square root of 56. So let's rewrite this with our new simplified square root. We're going to say x equals negative, let's simplify this too. Negative times a negative is a positive 8 plus or minus 2i square roots of 14. Let's simplify the denominator as well. 2 times 3 is 6. All right, now we can simplify this fraction at the very end. When we do, the only things we can simplify are these coefficients, these numbers in front. So the 8, the 2, and the 6. We cannot touch the I, and we cannot touch the square root of 14. So 8, 2, and 6, what are they all divisible by? They're all divisible by 2. So simplifying each of these numbers, 8 divided by 2, that becomes a 4. 2 divided by 2, that becomes a 1. And 6 divided by 2, that becomes a 3. So our final two imaginary solutions are 4 plus and minus this I times the square root of 14 over 3. These are our two solutions. All right. So if this last one was kind of confusing, I highly suggest you rewind and go back through it. This version right here, I taught my 5th period, and this version right here, I taught my 8th period. So please don't get confused by the wrong class periods way of doing it. Yeah. If you have any questions, write your questions down on your notes or on your homework assignment, and I will answer them tomorrow when I come back. If you have any more urgent questions, please send me an email, and I'll be happy to respond. All right, well, tomorrow we'll start our worksheet, the why did the mathematical tree fall over? Practicing using the quadratic formula. So again, if you're feeling confused, please go back through these notes problems and make sure you have a calculator. Thank you and have a great day.